start recording. Okay. So from yesterday, we already did some basic rules, okay, with basic integration, okay, together with rule 17, okay. Then required to do the exercises, so to actually get used to the formula. Okay, now we will continue with section C. Section C, some rules about trigo. Okay, we are required to know about trigo. So let's see. Yeah. Okay. So the difficulty of the question will be increases from one at a time. Okay. So over here, students are already expect to know the formula for section A and section B. And now students need to know how to deal with the trigo question. Okay, for trigo with power more than 1, change it into power 1 using trigo formula before integration. Yesterday we already have some example. Okay, how do we actually change the sine square? Okay, into sine square power 2 to power 1. Then we integrate them according to the different rule to get our answer. And for the sine power 3, we use the triple angle formula to change the sine power 3 into the power 1. Then only we integrate them. And rule 19, for multiplication of two trigo, you are expected to change it into plus minus of two trigo using trigo formula before integration. How we actually can use the formula of sine A plus B, sine A minus B to exchange the formula of this thing into the question that we want. Okay, so the next section that we're going to do is we're going to look at more example of the questions. Okay, let me open the questions. Okay, so I'm going to show you one by one. Okay, how to actually do these trigo questions. Okay, so number 1A. Okay, cotangent of square. So integrate cotangent square x dx. Okay, now all of you should actually look at your trigo list. Should actually take out your trigo list. So the trigo list will actually help you to determine what are the formulas that you know or you don't know. Okay, over here for cotangent, if you look at your trigo list, cotangent square x, we can actually change it into cosecant square x minus 1. Okay, the purpose that we actually change it into this, because from the section B, we have the formula for cosecant square. But from section B, I don't have any formula for cotangent square. So from section B, since for section B, I have a cosecant square, I can actually use section B to help me get the answer. Okay, and if the students get familiar with the trigo rules, then they are actually aware that, hey, the cotangent square can actually rewrite in this form. So over here, we can actually write the answer as negative of cotangent x minus x plus c. Done. Any questions? Are you okay? Can follow?
Yes.
Okay, good. Then what about b? Okay, integrate of cos square x dx. Over here, we will need to use, this is a cos square, power 2, okay? So I cannot use sine square because I don't have a sine square during, in my section B. I also don't have a cos square in my section B, okay? So I will need to use a double angle formula. The double angle formula tells us that I have a cos 2x equals to 2 cos square x minus 1. So if I rearranging the form, I will have a cos of square x equals to cos 2x plus 1 over 2. That means this question here, I can actually change it into a 1 over 2 of integrate cos of 2x plus 1 dx. Okay, so cos, as you can see, we managed to change the power 2 to power 1. Managed to change the power 2 to power 1 over here. Once I change it into this form, I can actually use the rule together with rule 17. So 1 over 2, okay, cos goes to sine of 2x. Because of the rule 17, there is additional 1 over 2 there. Okay, 1 over 2, 1 over 2 sine of 2x, then plus by this one x here, plus c. Of course, simplify the form, you have 1 over 4 of sine 2x plus 1 over 2x plus c. Are you able to follow?
Yes.
Okay, good. For c, okay, so a sine of 2x, cos of 2x, okay, let's see what actually happened here. Sine of 2x, cos of 2x. You realize that these 2x and 2x here, they are the same thing. Okay, so if you refer back to your trigo rules, okay, you realize that there is something very similar, that sine of something, cos of something together, that actually gives you the double angle formula. This is 2 sine of 2 theta equals to 2 sine theta cos theta. So you will see that there's a sine theta and cos theta here, where they are the same thing, which means this formula, this question of sine 2x cos 2x, it can be changed into 1 over 2 of sine of 4x. Sine of 4x, because the relationship is double and a half. The relationship over here for the double angle formula is actually double and a half. The double of 2x is 4x. So we use the formula, okay, of the integration rule. So I have a negative 1 over 2, okay, become cos 4x together with rule 17. I have 1 over 4 here plus c. In the end, you have a negative 1 over 8 of cos 4x plus c. So far, so good?
Yes.
Okay. So maybe I go for the question 2. Okay, question 2. Question 2, let's look at A. Integrate of 1 minus sine x over cos square x. Okay. So since I have a common denominator, so I separate them. So into 1 over cos square x minus sine x over cos square x. Okay, so 1 over cos, according to trigo, is secant square. And for my second term, I have sine over cos square. A pair of sine and cos give me tangent. And the 1 over cos give me secant. So that actually allowed me to use the formula immediately. So I will have This one goes to tangent, this one goes to secant plus C. Okay, as you can see, it's just familiarity to the formula. Okay, it's actually just to get used to it. So let's say I jump to maybe question G. Okay, to G. To G, I have an integrate of cotangent x minus tangent x squared dx. So I have a bracket square. Therefore, the very first thing that I need to do is to do expansion a minus b squared. So I have a squared minus 2ab plus b squared. So a squared minus 2ab plus b squared. Okay. The cotangent square here, again, from the section B, we don't have a formula for cotangent square. So we have to change it into something else. So the cotangent square, we change it into cosecant square minus 1. And the two cotangent x tangent x here, cotangent we know that is 1 over tangent. Therefore, the cotangent and the tangent will be cancelled off. Minus 2. And the tangent square here, similarly to cotangent, in the section B, we don't have a formula for tangent square. We don't have a formula for tangent square. Therefore, over here, I will need to change it into something else. We will change it into secant square x minus 1. Okay, so over here, then we simplify the word. Minus 4 dx over here. And what do we see next? So secant square, now I can apply the formula. So it becomes a negative cosecant square. Okay, cosecant square, apply the formula, become negative cotangent x. Secant square, apply the formula, become tangent x. Minus 4, now become minus 4x plus c. Done. Are you okay?
Yes.
Okay. Then maybe I go for question 3. Question 3a. So I have integrate of cos 2x cos x. Okay, cos 2x cos x. Cos and cos. Cos multiplied by cos. But the problem is these two, they are two different things. They are not the same thing. Okay, so therefore over here, we can actually refer back to our trigo list and try to identify the suitable formula that we actually can use. You realize that you can use something that look like this. Cos of a plus b plus cos of a minus b equals to 2 cos a cos b. Okay, hopefully your trigo list is with you. So for those students who are going to view the YouTube file later, you actually can pause and go and take out your trigo list to then to refer. Okay, you have this formula: cos of a plus b plus cos a minus b equals to 2 cos a cos b. Then over here, that you can see it fulfill cos a cos b in this formation. Therefore, I can write the formula. I can change this into the form of cos of 2x plus x plus cos of 2x minus x dx. Then we can get cos of 3x plus cos of x dx. You realize that, hey, finally I changed something, but two things that multiply together into the plus minus form. Okay, together with the cos rule and rule 17, I will have a 1 over 3 of sine 3x plus sine x plus c. Hence, you have 1 over 6 of sine 3x plus 1 over 2 of sine x plus c. Done. Okay. So let's look at another example. Let's say we have question F. Okay. 2 cos 4x cos 4x. Question 3F. Integrate of 2 cos 4x cos 4x. Cos and cos again. But, okay, you will see that this is cos and cos again. But the difference is these two, they are the same thing. Okay, these two, they are the same thing. So that means if I want, I can actually rewrite the form that being a square together. Cos square 4x. So if you look at your formula list, where can you find that 2 cos square something is actually in your double angle formula? It's actually in your double angle formula. So you can actually, your double angle formula actually look like this. You have cos of 2 theta equals to 2 cos square theta minus 1. Okay, you have this formula here. That means this question can be rewrite in the form of cos of wait, let me answer cos. Sorry. Okay, so from the 2 cos square 4x, okay, 2 cos square 4x, we have this form. We can actually rewrite it as a 8x plus 1. You can see the relationship is double and half. So over here, we can actually apply the formula. It will come 1 over 8 of sine 8x plus x plus c. That's your answer. Okay. Of course, if you don't want to apply this formula, we can still using the 2 cos A cos B form. Okay, it will actually give you the same thing, the same result. Are you okay?
Yes.
Okay, we're not going to do a lot first. Okay, so I'm going to let you do some exercise over here first. Okay, there is another part that I need to show you, which is the inverse trigo for the tangent. Okay, please wait. Where is my inverse trigo questions? Okay. There will be inverse trigo questions. Let me see. Let me delete the fountain first at the bottom. Okay. Okay. So this will be the inverse trigo questions, okay, for the 2020 syllabus. 2020 syllabus that you are expected to know. Okay. So how to actually solve these questions? Okay. From here, you can actually do it in this way. Okay. The formula. Okay. You can use the formula 1 integrate of 1 plus x squared dx equals to arctangent of x plus c, or you can use the formula a squared plus x squared dx equals to 1 over a arctangent of x over a plus c. Okay, you can do it in this way. So over here, therefore, the how to actually use the formula. Okay, let's say for 1a, you have integrate of 1 over x squared plus 9 dx. So first of all, the 9, the value 9, you need to read it in the form of square first. So I'll have a x squared plus 3 squared. Okay, once you write it in the form of square, you realize that you can actually fit with this formula. If fit with this formula, then you will write a 1 over 3 arctangent of x over 3 plus c. This is all what you need to do. Are you okay?
Yes.
Okay. I'm going to post the answer. Being it being and the trigo answer and the trigo answer trigo answer. Where's my trigo answer? Okay, so today work is just this. Okay, very little. I don't want to push a lot first, so that you have actually time to actually do with the question. Any questions that you don't know how to do, you can actually just text to me. Okay, I'm going to stop recording now and send the file to you. You can actually stay on the line to do your